In this video, we'll review how to do transformations of linear functions. Now to begin, let's think about the three ways that we can express a linear function. We can use standard form, that is ax plus by equals c. We could use slope-intercept form, commonly written as y equals mx plus b, or more generally, y equals ax plus k, where a is the stretch and k is the vertical transformation. Or we could use point-slope form, y equals m, quantity x minus x1 plus y1, x1, y1 being a point, or more generally written, y equals a, quantity x minus h plus k, where hk is some point on the line and a is the stretch. Let's take a look at point-slope form and let's see what that really tells us. Remember that in point-slope form, either the m or the a value is the slope. The x1, or generally formed the h, that is the horizontal translation, and the y1 or the k is the vertical translation. Let's look at this form and let's see how we can use this to predict the transformations of linear functions. Below, I have four examples of new functions g of x that are some type of transformation of the original function f of x. We're going to look at each of the four and describe what the transformation is. In example 1, g of x equals f of x plus 2. The new function g of x is the original function f of x plus 2. What's the transformation? Here, we're adding 2 to the value of f of x. We're adding 2 to the outputs. If we're adding 2 to the outputs, notice it's like having the k value. It's a vertical translation. So here, because we are modifying the outputs, we're translating up to units. Now look at example 2. Here, the new function g of x is the original function f of x minus 2. Again, we're taking and modifying the output f of x, but this time we're subtracting 2 from it. So it's still changing the outputs. The only difference is now we're translating down 2 units. Again, it's like having that k value. In example 3, the new function g of x is f of x plus 2. Notice we're not adding 2 to the outputs anymore. Now we're adding 2 to x. This is like having that h value. This is going to be a horizontal translation because we're changing inputs. In this case, we're translating 2 units to the left. Take a look at example 4 and see if you can predict what's happening. It's a lot like example 3. The new function g of x is f of x minus 2. We're translating to the right because we're taking x and we're modifying it. We're changing the inputs. Notice when it's in the parentheses, it's a horizontal translation. Outside of the parentheses of x, it's some type of vertical translation here when you're adding or subtracting. All right, so let's look at a couple more examples here. What we can do with this. All right, we're going to graph the function f of x equals 2x. f of x equals 2x is a pretty simple function. The slope is 2, and the y-intercept is 0, 0. So let's go ahead and plot 0, 0. And then we're going to find new points by moving up 2 units and 1 to the right. We'll do that a couple times. You get enough points, we can see that it's a line. And we can see exactly where the line's going. There's f of x. Now I'm going to take a new function, g of x, and say that the new function g of x is defined as f of x plus 3. The new function is the original function plus 3 more. What's the transformation? Like the previous examples, we're changing the outputs. We're taking f of x and we're adding 3, which means this is a vertical translation and up 3 units because we're adding. So how do we plot the points? How do we graph what the new function is going to look like? Well, if we're taking a line, the function here, and we're adding 3 to the outputs, that's just going to translate it up 3 units. So I can take each of the points on that blue line, f of x, and just move them up 3 units. So I can take that first point we plotted, 0, 0, and just count 3 units up. So if I take 0, 0 and move it up 3 units, that becomes 0, 3. That's that new red point. And if I take the next point that I have marked, which is 1, 2, and move that up 3 units, 1, 2 becomes 1, 5. That's the second red point. Now I'll take one more. I can kind of see what it's looking like, but I want to be sure. If I take the point 2, 4 and move that up 3 units, sure enough, that becomes 2, 7, and I can clearly see what we have. We've got a new line that is parallel to the original line, just moved up 3 units, because that was the transformation. The new function g of x was f of x plus 3. So to do this, we could just plot the original problem, the f of x equals 2x, and then translate it based on the new equation, g of x equals f of x plus 3. But how else could we do this? Well, we could find what the equation of the new function is. We knew that g of x equals f of x plus 3. Why not substitute what we know about f of x and add 3 to it? F of x is 2x, so we could substitute 2x and add 3 to that. Those aren't like terms, so we're stuck. It's g of x equals 2x plus 3. That is the equation of a line, where the slope is 2 and the y-intercept is 0, 3. Well, let's go back to that red line we just used a minute ago. If you notice, the y-intercept is 0, 3. That's the first point we plotted. And then all the other points on that line are 2 units up and 1 unit to the right of that original point. The slope is 2. So we really did plot that new equation, we just didn't know what the equation was. And this just gives us another way to do it. We don't need the equation, but we could use the equation instead. Well, how else could we do it? Well, a third method would be to use a table. We could make a table for x and f of x, and then add a third column for g of x, where g of x is the output table f of x plus 3. Well, to find f of x, we got to go back to the original equation. F of x equals 2x. That just means we're going to take each of the inputs and multiply by 2. So negative 1 times 2 is negative 2, 0 times 2 is 0, 1 times 2 is 2, and so on. Once we have the f of x column filled in, now we're ready for the g of x column. G of x is f of x plus 3. So we'll take each of the values in the f of x column and add 3 to it, and that'll be the g of x value. So if we take the negative 2 and add 3 to it, negative 2 plus 3 is going to be 1, and that's the first value of g of x. And we'll just keep doing this. 0 plus 3 is 3, 2 plus 3 is 5, 4 plus 3 is 7, and 6 plus 3 is 9. Now let's go back and let's look at that red line again. If we look at the x value, negative 1, in the table, and the g of x, not the f of x, the g of x is the y value, the coordinate would be negative 1, 1. Let's look at the red line. Did we plot a point at negative 1, 1? Now we didn't mark it with a point, but if you notice, the graph does go through negative 1, 1. It also goes through the next point, 0, 3, from the table, which is the first point we marked, and then 1, 5, 2, 7, and even 3, 9, even though we didn't put a point there. So we could use the table and then plot the points on the table to get the graph. Also notice that those points on the table could be found using the equation. We knew that g of x equals 2x plus 3. If we take the x value, negative 1, multiply it by 2, and add 3, let's see what we get. 2 times negative 1 is negative 2. Negative 2 plus 3 is in fact 1, which is the first output value in our table. So we could also use the equation to fill in the table to fill in the line. So there's several different ways to do it. The easiest is just plot the original function and just translate it up and down or left and right depending on what the equation is. Well, let's look at another example here. In example 2, the new function f of x is now x plus 4. The new function g of x is going to be f of x minus 2. Let's plot the original function. Here the slope is 1, but now the y-intercept is 0, 4. So we'll start at 0, 4 and find new points by going 1 unit up and 1 to the right. We'll get enough points that we can see what the line looks like and then draw the line. There's f of x. Now for g of x equals f of x minus 2, what's the transformation? Here, we're translated down 2 units. We're taking the outputs and subtracting 2. So we can take all of the points on that line and just move them down 2 units. Now I don't have to do with all of them, I just got to do enough to be able to see it. So let's start with the y-intercept. If we take 0, 4 and move it down 2 units, it becomes 0, 2. There's a point on the new line. Then we can take the next point, which would be 1, 5, move that down 2 units. It becomes 1, 3. Let's grab one more. Let's take 2, 6 and move that down 2 units. If we take 0, 6 and move it down 2 units, it becomes, 2, 6 becomes 2, 4. And I can see clearly what the new line looks like. This is going to be g of x. It's parallel to the original, but just translated down 2 units. So remember, we can always plot the original function and just translate to find the new one. But again, how else can we do it? Let's look at that equation. Well, if we knew that the original function was x plus 4, and the new function is g of x equals f of x minus 2, well, let's just take the x plus 4 and substitute. The new function is g of x equals x plus 4 minus 2. This gives us x plus 4 minus 2, which is really just x plus 2. So g of x equals x plus 2. This new function has a slope of 1 and a y-intercept of 0, 2. And if you notice the red equation, the one that we graphed over there, the line, has a y-intercept of 0, 2 and a slope of positive 1. So this equation does describe the line we plotted. Now that third way is the table. So we can make a table. I'd probably pick the same x values. We'll find the f of x values. F of x is going to be x plus 4, which means take the original column values and add 4. Once we know those, we'll find the g of x values by taking the f of x values, that is the second column, and subtracting 2 each time. All right, here we go. If we take negative 1 and add 4, that'll be the first f of x value. Negative 1 plus 4 is 3. 0 plus 4 is going to be 4. 1 plus 4 is going to be 5. 2 plus 4, and then 3 plus 4. To find the g of x values, we're going to take all those blue values for f of x and subtract 2. 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3, and so on. Notice the coordinates negative 1, 1, 0, 2, 1, 3, 2, 4, and 3, 5 all describe points that are on that red line that is our g of x line. We could use the first column and the last column to find coordinates that would be on the new line, and then plot the coordinates to get the line also. So you have 3 ways. You don't need to use all 3. You just need to pick the one that you're most comfortable with. Either plot the original, find the new one, or find the new equation to plot the new line, or use a table to find the new line. Now let's look at a third example here. Here, f of x is negative 2x plus 1, and g of x equals f of x plus 4. Why don't you pause the video, try this one, and then resume the video when you're ready to check your answer. I'll give you a moment. All right, hopefully we've had a chance to do this. In the original function, the slope is negative 2 and the y-intercept is 0, 1. So let's go ahead and plot that line. Keeping in mind it is a negative slope, so it goes down and to the right. The transformation this time is translated up 4 units. So let's just take all those 3 points that we have, they're clearly marked, and just move them up 4 units. There's the f of, or g of x function. Now we could also do it with the equations. I don't know if you did that or not. We could take the negative 2x plus 1 and add 4 to it. So g of x equals negative 2x plus 1 plus 4, which is really just g of x equals negative 2x plus 5, where the slope is negative 2 and the y-intercept is 0, 5. We could start by plotting at 0, 5 and just move down 2 units 1 to the right each time. Or we could take a table. Here, we got to multiply each of the inputs by negative 2 and add 1. So I would get these points. And then, to find the g of x, just add 4 at each of those blue values. The coordinates would be negative 1, 7, 0, 5, 1, 3, 2, 1, and then finally 3, negative 1, which are points on that red line. Now let's look at one more example here. We're going to have to go kind of quick. Here, f of x equals x plus 3, and g of x equals 2x plus 1. I had 2 original functions, and now there's a third function, h of x, which is f of x plus g of x. The transformation is not as easy to see. It's not just translated up or down or left and right. So we got a little bit more going on here. We're adding 2 functions together. To do this, we're going to take the original functions, and I'm going to plot both of them. So here's f of x. G of x has got a slope of 2 and a y-intercept of 0, 1. So let me plot that one. To find the new function, h of x, I'm going to add the values of each of the f of x and g of x. So at x is 0, I've got the f being up 3 and the g being up 1. Well, 1 plus 3 tells me the new one is going to be at 4. Now I go over to where x is 1, and I had values that had a y value of 4 and 3. 4 plus 3 is 7. So my new one's going to be up 7. And if I go to where x is 2, g of x and f of x are both up 5. 5 plus 5 is 10. So my new one's up 10. So I'm just adding the y values for each x value, and I can find the new line. But we could also do it just like we did the other problems. We could add the equations together. F of x and g of x could be substituted in and added together. X plus 2x are my like terms there. That's 3x, and 3 plus 1 is 4. So h of x is 3x plus 4. And that's what we see in the graph. It's got a slope of 3 and a y-intercept of 0, 4. Or we could also make a table. Find the f of x values, find the g of x values, and then add them together. The new points would be negative 1, 1, 0, 4, 1, 7, 2, 10, and 3, 13, which, if you look at that black line, all describe points on the line. So again, we could use any of these 3 approaches. All right, thank you for watching this video, and hopefully it helped you to understand transformations of linear functions.